morning, guys. I had several questions about empirical formula yesterday. It is new content. I know it's hard for us to start anything new while we're in the middle of everything with distance learning, but I wanted to take some time to go back and try to explain to you empirical formula. It is a very important part of chemistry labs. Just a scenario here. Let's say that you are given a compound and you are told that it has 63.7% carbon and 16.3% hydrogen and some other chemical, and you have to figure out the formula for that. And the way you would do that is to find the empirical formula from the percent composition, and from there then we can find the molecular formula of the compound. The empirical formula is the smallest whole number ratio of elements in a compound, and then the molecular formula is the actual amount of each one. So we're going to be looking at both of those over the next couple days. So let's look at the steps for determining the formula from percent composition. And it's the same stuff that I showed you yesterday. Yesterday I wrote it out, but I just wanted to take a couple seconds to do this video today for you. So the first thing you're going to do, we know that all percentages add up to 100%. And since we know that all percentages add up to 100%, we can take the percent of each compound and just set the percentage equal to 100 grams, and then that percentage would be equivalent to the amount in grams out of 100 grams of the compound. So that's the reason that we do that. That way it just gives us it gives us an easy starting point. We know the percentages out of 100%. Now we know the amounts out of 100 grams. At that point, you're going to convert the grams to moles for each element of the compound using the molar mass. So for carbon, if I had 63.7 grams of carbon, I'm going to set that equal to 1 mole of carbon over the molecular formula, which is 12 grams of carbon. Divide 63.7 by 12, and that's going to give me the number of moles. I would do that for each element that I would be working with in my compound. Next, you're going to divide the mole answer by the smallest mole answer. Here's where it gets a little confusing from step 4 on. The smallest mole answer is easy. You know what is the smallest number, and you're just going to divide every answer that you get for converting the elements from grams to moles by that smallest mole answer. So the smallest amount that you get in an answer, you're going to divide the rest of those by that. If you don't have a whole number, then you have to multiply by the smallest whole number you can use to get that to a whole number, to get your decimal to a whole number. You can use a 10th off. So like yesterday in the example, when we multiplied by 3, we got 6.9. Okay, and 6.9 easily rounds up to 7, so we just use it that way. And then if you divide through and you get whole numbers, these are going to be your subscripts. You don't have to do anything else. So it would be, if you haven't looked at yesterday's examples and you haven't worked number 2 in the practice problems, this would be a really good spot for you to do that. And then that will help you understand better what steps 4 and 5 mean. All right, so here's a little poem. Kind of get it stuck in your head, and that will help you memorize the steps of this. So here's your poem. It is percent to mass, mass to moles, divide by small, multiply by whole. So you would change your percent from the percentage to the mass out of 100 grams. You're going to divide that mass by the molar mass to give you the number of moles. Divide by the smallest mole answer, and then multiply by whole numbers if you need to. Only if you need to. So let's look at an example. What's the empirical formula for a compound that's 21.2% nitrogen, 6.1% hydrogen, 24.3% sulfur, and 48.4% oxygen? And so what we're going to do first is set all those equal to grams. Then we're going to divide by the mass. Now keep in mind, guys, in the PowerPoint, I do use the decimals, but you can round to whole numbers. It's perfectly fine to round to the whole number for this. Then I would do my math for all of these. You see how easy that is. And then I would discover that sulfur gives me the smallest mole answer. So I'm dividing the rest of those by 0.758. Okay, now in my example here, that comes out to 2. Hydrogen would come out to 7.97, which approximates to 8. You can round up to 8. Sulfur has a whole number of 1 because 0.758 divided by 0.758 is 1. And then oxygen is 3.03 divided by 0.758, and that gives me 4. Now, this gives you a good example because each of these came out directly to a whole number, but this guy right here gave me a decimal. Now, in this case, it was close enough that it could round up automatically. If it had not been, I would have had to multiply that by a whole number. So I would have started with 2. If that gave me something really close to a whole number that I could round up by 1, then I would stop there. If not, I would go to 3. Then I would go to 4, 5, so on. You want to start at the smallest number that you can use and move that up as you go. So just keep that in mind. And then my empirical formula is going to be N2, because we see here is N, and it has a mole ratio of 2. So N2, hydrogen would be 8, sulfur would be 1, and oxygen would be 4. So the subscripts are the numbers that we have determined from changing the percents into grams. Okay, let's look at another example. What's the empirical formula for a compound that's 69.8% iron and 30.2% oxygen? So I change my moles or my percentages into grams, 69.8 grams of iron and 30.2 grams of oxygen. I convert both of those to moles. And then I divide by the small. So you see here that iron has the smallest amount of moles. So I'm going to divide both of those by 1.25. That gives me 1, obviously, for iron. And it gives me 1.5 for oxygen. Okay, so here's where we have to multiply. In this case, we're going to multiply each of these by 2. Remember, we start with the smallest number our next number besides 1, which would be 2. So then, when we multiply that by 2, we get 2 for iron and we get 3 for oxygen. And those are both whole numbers, so we can stop right there. So then that gives me the formula of Fe2O3, which is my empirical formula for this. All right, I hope that helps. Please let me encourage you guys, make sure that you constantly are trying to be in touch with me, that you're working on your assignments. I'm really proud of the work that you all have done. I know that several of you all have been in touch with me over questions of the quiz and things like that, and you've done a really good job. So just keep it up. I'll see you all later. Bye.